Morning. So I've populated the prototype board, so you can see we can do this. The switches are there, the solid state switches, relays. Sorry, I keep on calling the wrong name. And I've been testing it, and during the testing, I found that my power supply has a common problem, which is that I'm guessing that it's the same problem, that it causes a reboot loop. There's a bridge rectifier in the front panel board that gets hot, so I've had to put some fans on it so that it runs for more than about 5 minutes, because otherwise it'll just, after 5 minutes it'll stop. So it's going to be a bit noisy. So if I power up the board, so at the moment some of the relays are turned on. I'm trying to film this properly. So I've turned on that one and that one. I've got the diode shorted. I'm measuring the current through here. Also switches, it's difficult to tell, difficult to read. W, O, W1 and A and D. So there's 4 switches. I've bypassed the LED, so there's current limit resistors 100 ohms, 100 ohms, no diode. So if I turn this on now, so with 12 volts, we get 40.6 milliamps. So that's, that's 0.4 milliamps, 12 volts. So now, okay, so I need also to know what the current is that's driving the LEDs, if I've got that right. Where's that focus? Oh, there it is. The internal LEDs, I just want to check that. So we got, so at the moment there's 12 volts, 40, it's changing. Why is it changing? 40.2 milliamps. So I just want to know the on, that's so I can get the on resistance of the thing, which is, just let me get a calculator. So 12 volts, 0.04068 at the moment. So 294 ohms, or say 295 ohms. So minus the 200 ohms, so 95 ohms divided by 4. So each switch is 23.75, which I think is about right. That's rough. That's pretty good in spec, I think. So that means they're probably turned on correctly, I hope. So now I just need to try to measure the input current. So now it's going to bridge this. These LEDs are bright, and I want the bit of organisation, I think. This is not good. So Just want to measure the voltage across the one of these. No, that's not right. B, where's B? Or A? And let's turn on WO. So I need to measure the current across that R3. Sorry, the voltage across R3. Where's R3? There. So it's 3.57, 3.58. So maybe I should try another one. D, which is R18. 3.58. That's good. Over 768. No, it's not. It's 820. It's 820. Ah, the power supply just failed, so the fan doesn't work. Excellent. So it just rebooted. Yes, so definitely I've raised an issue. It's under warranty, apparently, I think, should be. But if I have to pay for shipping, it's probably not worth it, and it sounds like it's like I've seen a picture of the fix, the probable fix, which is just a heatsink glued onto the diode bridge. So that's 4 milliamps. 4 milliamps. Okay. So I need to look at the specs. So the switches that I'm using, that's the relay, solid state relays are AQY280EH. And so looks like the maximum LED forward current is 50 milliamps. So, and currently it's 4 milliamps. The peak forward current of the device is an amp. That's the 4-pin, so I'm using the 4-pin dip one. So it says here the max, I don't understand what that means. The maximum forward LED operating current is 3 milliamps. The minimum is 1.8. So I'm probably going to have to modify that limiting resistor, make it a bit higher and get it in that range, I think. And the maximum on, so I'm calculating the on resistance is 23.75 ohms. Well, I don't need to be that precise, but so it's just a bit less than the maximum guaranteed, which is good. So I think they're roughly working. So yeah, I'll have to modify the resistor. I also need to get my power supply fixed because the fan that I put there to cool it doesn't work. So it just, instead of every 5 minutes, it's something like every 10 minutes, I think, that it reboots, which is really annoying. At least it fails safe. It doesn't come back up with the power on, which is good. So the other tests that I plan is to try to, well, I have no way of testing up anywhere near thousands of volts, but I want to at least test this thing with 240 volts or something like that, maybe higher if I can rectify it. So a really high voltage, high DC voltage, just to make sure that it doesn't. Actually, don't know how to test that safely. It should be pretty trivial because I know that they're kind of working. Just trying to think. And then after that, I will use an Arduino to try to implement the algorithm and see how that works. So try to connect it to the ADC, and I need to order some more because I thought that I'd ordered enough of these solid state relays to do both of the test boards, but I didn't. I don't know why that was. I think I couldn't count. But I want to use one as the transmitter and one as the receiver, just to test the idea of the cable tester. Yeah, they're not at $2 there. I think, yeah, I looked before. The DigiKey's got a lot more of them. $2.60 each. But I think, given that they seem to work, I mean, I'll probably do some more tests. They seem to work. I might buy a bunch of them now. More than enough. So because I intend to try to test this thing to destruction. That was the idea, just to make sure that the final cable tester is safe. So because it's got to work in an environment where it's possible that it could be connected to 3-phase. So it could get connected to 400 volts AC accidentally. I think that's about the max that the aircon that my son works with uses up to. Although they use variable frequency drive stuff, so but yeah, I think 400 volts max. But the level of current, like really low impedance, like it's much more current than I'm used to. So if you get something wrong, bad stuff could happen really quickly. Anyway, that's about all. Thanks for watching.